Dear student, in today's session we will discuss atomic structure, and in this section we will discuss discovery and atomic models, electromagnetic radiation, quantum nature, Bohr's atomic model, quantum mechanical concepts, wave nature, quantum numbers and electronic configuration. So we'll start with the discovery and atomic models. First theory regarding atom is Dalton theory, and Dalton gives some points about atoms. He told that matter is made of smallest indivisible particles, that is atom. So smallest particle indivisible, that is atom. And he told that atom of an element, for example element is nitrogen, then he told that atom of, so first of all we discuss discovery and atomic models. First theory about atom was Dalton theory, and Dalton told that matter is made of smallest indivisible particles, and these particles are known as atom. According to Dalton, he told that elements are made of smallest indivisible particles known as atom. He also told that atoms of same element are same, identical. It means if element is nitrogen, then this element was made of nitrogen atom only. If element is oxygen, then this element is made of atom only oxygen. After that, as discovery of electron, proton and neutron came, then Dalton theory was felt, and next model was Thomson model, that was also known as plum pudding model. He told that atom is spherical in shape and mass of an atom is uniformly distributed in entire space of the atom and electrons are embedded into it. This model was like, according to this, atom is like watermelon. So after the Rutherford model, Thomson model was also felt, and in Rutherford model, what all points are given? In Rutherford model, this model was based on alpha particle scattering experiment. In this case, Rutherford take alpha particle and gold foil, and alpha particle are colliding, projectiling, next model was Rutherford model, and he told alpha particle scattering experiment to explain his model. According to this, a nucleus is tiny dense positively charged nucleus, atom is mostly empty space. Next model is Rutherford model. According to Rutherford, nucleus is tiny, dense, positively charged, and atom is mostly empty space. He explained his model by alpha particle scattering experiment, and when alpha particles pass through atom, then we see that most of the alpha particles goes in a straight line without any deflection, and some alpha particle deviated from some angle, and very less number of alpha particle will come with 180 angle. It means he concluded that a dense material, positively charged material are in atom, that is known as nucleus. This model was also felt when classical theories comes. According to this theory, every accelerated charge particle when revolve in circular path, some amount of energy will emit and energy loss occur continuously, and finally this charge particle collapse into nucleus. So this model was also felt. Then next, if we talk about Bohr model, before that some points are there about cathode rays. Cathode rays is nothing but a negatively charged particle, and electrons present in atom. Rutherford scattering experiment, most alpha particle pass undeflected, a very small fraction undergo large deflection. So we conclude that positive charge almost are concentrated in a very small nucleus. Then this is a simple question regarding Rutherford alpha particle scattering experiment. So what is this? In Rutherford's alpha scattering experiment, most alpha particle pass through the gold foil without any significant deflection. This indicates that. So this is atom, and in this question is given that most of the alpha particle pass through gold foil without any significant deflection. It means most of the alpha particle pass through an atom. It means most of the part of an atom is empty. First part, positive charge is uniformly distributed. This is wrong. Positively charged is only concentrated at center of the atom. Most of the atom is empty space. This is correct. Electrons are present inside the nucleus. That is wrong. Electrons are in circular path. The nucleus occupies most of the atomic volume. Nucleus occupies very small volume. So your answer is second. Next, electromagnetic radiation and quantum nature. Beta, electromagnetic radiation has two field component, electric field, magnetic field. Both field component are perpendicular to each other, and I can say very easily that electric field, magnetic field, magnetic field and wave, these all three are perpendicular to each other. If electric field in x direction, magnetic field in y direction, then propagation of the wave will be in z direction. So this is according to electromagnetic radiation. EMR travels with the velocity of light 3 multiplied 10 raised to power 3 multiplied 10 raised to power 8 meter per second. There is no need of medium to travel EMR, electromagnetic radiation. Light is a type of electromagnetic radiation also. Light is a type of electromagnetic radiation also. We have a simple relation between nu, frequency of radiation, and wavelength of radiation. Nu equals to c upon lambda. C is speed of the light, 3 multiplied 10 raised to power 8 meter per second. Frequency and wavelength. Also, according to Planck's theory, if an object absorbs energy, then it absorbs energy by small packets. These small packets are known as photon, or if light, according to Planck's quantum theory, energy absorbed by an object in the form of smallest packet. These smallest packet have certain amount of energy, and if energy of one packet is h nu, then energy of n photon will be n h nu. This is total energy E बराबर n h nu. आप लोग if we put data of nu, then you will find out n h c by lambda. This will be energy. Here is h is Planck constant, and value for this is 6.62 multiplied 10 raised to power minus 34 joules second. According to this, if frequency is increases, then lambda is decreases, and if I talking with this wavelength decrease, energy increase. It means opposite relation between wavelength and energy. And energy and frequency, you know, nu is frequency. Energy and frequency are directly proportional. It means when we increase frequency, then energy also increases. Photoelectric effects support the particle, photon, nature of the light, and de Broglie wavelength also explain wave nature also. And it means dual nature, particle nature as well as wave nature. Lambda equals to h upon p. H upon p is momentum, that is mv. So next, according to some basic formulas, we seen nu barabar c by lambda. Energy of each photon is h nu. You can write hc by lambda. For n photon, energy will be n h nu. You know lambda equals to h upon p, and you also know momentum is this. And we can write also, if lambda and relation between kinetic energy 2m kinetic energy. What is this relation? you know kinetic energy equals to half mv square. You have to multiply m here, so this will be this and this will be m kinetic energy. You have to multiply by 2 m kinetic energy. This will be mv, and mv, it means momentum. So if kinetic energy is same, this is constant, then you can write lambda equals to h upon root 2m. So these are some basic formulas related to atomic models. Next, this is very simple question. A photon has wavelength this, frequency is approximately. So you know frequency will be nu equals to c by lambda. So you can write nu equals to c by lambda. You have to write nu, this will be 3 multiplied 10 raised to power 8 meter per second. Lambda is this, you have to convert into meter, and you know how we can convert this into meter. So nanometer 10 raised to power minus 9 meter, then you will get answer in hertz. So whatever will be answer, you can check accordingly. Next, Bohr's atomic model. Beta, Bohr told some points regarding his model. Bohr told 3 points, point 1, point 2 and point 3. He told that an electron is revolving in circular path. When he revolving in circular path, you know mv square equals to r, and inside will be k ze square upon r square if radius is this. So he told that this force will be balanced by this. So this will be mv square upon r k ze square upon r square. Second, he told that angular momentum of an electron is integral multiple of h upon 2 pi. Angular momentum of an electron is integral multiple of h upon 2 pi. Then he told that mvr equals to nh upon 2 pi. He also told that if an electron comes from higher energy to lower energy, he emit energy, and energy difference, this will be delta E, and if the radiation of emitted wavelength is lambda, then you can write hc by lambda. So when this electron goes from lower to higher energy level, then he will absorb energy. Energy absorb means some photon having wavelength lambda, and you can write delta E equals to hc by lambda. Lambda is wavelength of the photon. So these are the points related to Bohr model, and by these equations you can find the formulas of radius of electron in particular cell orbit. You can also find velocity formula. So now we will discuss radius will be 0.05 529 multiply by n square divided by z angstrom. N is the cell number, z is atomic number. Velocity will be 2.18 multiplied 10 raised to power 6 multiply by z by n meter per second. Energy will be minus 13.6 z square divided by n square electron volt per atom. Okay. Proportionality also we can check. Radius is directly proportional to n square, radius is inversely proportional to 1 upon z, velocity is directly proportional to z, velocity is inversely proportional to 1 upon n. Energy is directly proportional to minus z square is directly proportional to minus 1 upon n square. So these are the formula. Radius. Also one thing is spectral line lambda. 1 upon lambda equals to rz square 1 upon n1 square minus 1 upon n2 square. This term should be positive, so arrange n1 and n2 accordingly. R is Rydberg constant, Z is atomic number, lambda is the wavelength. Next, hydrogen-like species. Hydrogen-like species means only one electron should be there. Ionization energy. Ionization energy means what? Energy at infinite is 0. Energy at n equals to 1. We have to calculate. So energy equals to n equals to 1 is minus 13.6 z square divided by n square. N should be 1. So this is energy of this level. Final will be 0. Initial is this. So difference will be 13.6 multiplied by z square. So this will be ionization energy. Next, Bohr model is only applicable for single electronic species. So next question is, the energy of electron in second orbit is of helium plus is. So we know energy formula. Energy equals to minus 13.6 z square divided by n square. Minus 13.6 z, where is z? Helium. For helium this will be 4 and second orbit this will be 4. So your answer will be minus 13.6 electron volt. Next, quantum mechanical concept, wave nature, Heisenberg's uncertainty principle. You know, delta x, delta x, delta p greater equals to h upon 4 pi. This is uncertainty in position. This is uncertainty in momentum. This is Planck constant. And delta p, that is m delta v. So next, in Schrödinger wave equation, psi is wave function and psi square mode is probability density of finding electron. Orbital is a region of high probability of finding an electron. So quantum mechanics replaces fixed Bohr orbit with orbital probability distributions. These are the points related to quantum model, quantum mechanical model. De Broglie concept has lambda equals to h upon mv for an electron accelerated through a potential difference voltage V, then you know lambda equals to h root 2 m kinetic energy, and kinetic energy will be qv. Q charge, V voltage difference, and when we are talking with electron, then for 6.62 multiplied 10 raised to power minus 34 root to 9.1 multiplied 10 raised to power minus 31 kg, charge of electron 1.6 10 raised to power minus 19, and voltage will be V. Then you will find this relation 150 upon V, and if you are putting voltage in volt, then lambda will be in angstrom. Next, a simple question. Velocity of electron is double, its de Broglie wavelength becomes. So you know what is the relation between lambda and velocity. So you can write lambda equals to h upon mv. आपने इलेक्ट्रॉन की वेलोसिटी को डबल करा, तो if velocity is double then lambda will be half. So your answer will be lambda by 2. In next, we are talking about quantum numbers and electronic configuration. Beta, next we will see quantum numbers and electronic configuration. So what is requirement, that what is need so that we have to study quantum numbers? So what is basic need is that we have to find exact location of an electron in an atom. For that, what we have to do, you have to understand something like this. This is nucleus and this is an atom. This is nucleus, this is atom, and there are different cells. Here electron is present. So when we want to reach to electron, you have to know first orbit, then orbit means cell, then you have to find subcell, then you have to find orbital, and then find to spin of electron. You have to find first of all orbit, then subcell, then orbital, then spin of electron. If you want to find orbit, then you have to know a number that is known as principal quantum number. Principal quantum number tells about the orbit number. Next is another quantum number, that is azimuthal quantum number, which tells about subcell. Next quantum number is magnetic quantum number, which tells about orbital, and finally quantum number, spin quantum number, which tells about spin of electron. So principal quantum number has value like 1, 2, 3, 4, 5, likewise, etc. and so on. If we want to know azimuthal quantum number, then this has value 0 to n minus 1. Magnetic quantum number has value minus L to plus L, and spin quantum number has 2 value plus minus half. These are the points related to number, principal quantum number, azimuthal quantum number, magnetic quantum number, and spin quantum number. Now we start something related to these formulas. Number of orbitals. If you have principal quantum number, this is particular subcell. In this particular subcell, if you want to find out the number of orbital, then this will be the 2l plus 1, and maximum electron will be 2 times of this, because one orbital can accommodate maximum 2 electron with opposite spin. If you have subcell is n, then n square is the number of orbitals and 2n square is the maximum number of electron. So next we can see we have to write electronic configuration, and for that we have to follow 3 electronic configuration rule. First is Pauli exclusion principle. What tells this principle? He tells that an orbital can accommodate maximum 2 electron with opposite spin. It means you can only fill 2 electron. You cannot fill like this, and also you cannot fill with same spin also. It means if you have to fill more than 2 electron, then spin automatically will be same. So we cannot write this also, we cannot write this also. Maximum 2 electron with opposite spin should be present. Next principle is Bohr principle. According to Bohr principle, this Pauli principle was given for single orbital. Bohr principle was given for different subcells. Like if you want to fill electron in 1s, 2s, 2p, 3s, 3p, so first, this rule will decide order of filling electrons in increasing order. He tells that electrons are filled in various subcells according to increasing energy order. Increasing energy order, and increasing energy order is decided by n plus L rule. What is n plus L rule? He tells that if n plus L is high, then energy also high, and if n is same, then second thing is what? If n plus L is same, then if we increase n, then energy also increases. n plus L increase होने पर, if n plus L increases, energy also increases, and if n plus L is same, then energy also increase when n is increases. So I have this question 6s, 6p, 5d, 4f. I have to decide energy order. So there is 6 plus 0, 4 plus 3, 5 plus 2, and 6 plus 1. What is this? This is n plus L. N is 6, L is 0, 4, L is 3, 5, L is 2, 6, 1. So this is 6, this is 7, this is 7, this is 7. So what is the order for deciding energy? First we have to check n plus L. N plus L is increasing for this to this, then energy also increases. When n plus L same, then on increasing n, energy also increases. So this is correct energy order. Last rule is Hund's rule. What is this? Hund's rule is given for degenerate orbitals. Hund's rule is given for degenerate orbital. In degenerate orbital, electrons are filled up. Degenerate orbitals means orbitals of same energy level. Orbitals of having same energy. So I can say this is for degenerate orbital. In degenerate orbitals, electrons are filled in such a way so that electron repulsion can be minimized. For that you have to fill electron. Likewise, you have to maximize unpaired electron so that electron repulsion can be minimized. After that you have to pairing. So in short, I can say this can be as a trick. You have to fill one electron. You have to fill one electron with the same spin. With the same spin. After that, you have. After that, you have to start pairing. So there are three fundamentals line or points for Hund's rule, that we have to fill one electron with same spin. After that you have to pairing. Some examples are there and I want to ask that where which rule is followed or which is not followed. So what is this? I have some simple examples like this. So I want to ask for Pauli principle, Bohr principle and Hund's principle. So this is, I think, I assume 3s, this is 3p. So first of all this is completed, after that this is fill up. So Bohr principle is followed. Pauli principle is for one orbital. He tells that only 2 electrons are filled up with opposite spin. 2 electrons are filled with opposite spin. Hund's principle says that one electron with same spin, there is no issue. Now I made correction that this, then this principle is not followed, because first of all we have to fill up this. After that, what about Pauli? Pauli is correct. According to Pauli, an orbital can have maximum 2 electron with opposite spin, and Hund is not followed because you have to fill up with same spin. So you can say likewise. Some electronic configuration exception also present. CR, in CR you have to write organ 18, then 4s1 3d5. According to us, this should be organ 18 4s2 3d4, but due to half filled electronic configuration, sorry, this arrow goes to this side. Sorry, what I am saying that in D there are 4 electrons. If this electron goes to this, then this configuration can be achieved. This is half filled configuration. Half filled configuration is half filled configuration are more stable than normal configuration. And in case also this theoretically, if we follow these 3 rules, then you will find 4s2 and 3d9, but fully filled configuration are more stable. Then this electron will move this side. These are the electronic configuration exception also. Next is a simple problem. What is this? Which set of quantum number is not possible? So, first of all, n is 3, L is 3, m is -2. This is correct. This is also correct. Why this is wrong? We know that n greater than L should be followed. So n is 3, then L should be 2. 1 likewise. So this cannot be similar. And I think this is also correct. So your correct message is this, because in this there is no issue. N greater than L, n greater than L also, n greater than L. M is what? M is -L2 plus L. So your L is this. So M can be -2. L is 1. M can be this. L is this. M can be this. And MS, and spin quantum number may be plus half, minus half, plus half, minus half, etc. Next, there are some simple questions. Which relation connects wavelength and frequency? So you know nu okay. So which relation are true according to wavelength and frequency? Then this is nu equals to c by lambda. So you can say c barabar nu lambda. This is correct. Maximum electron in n equals to 3. So you know n equals to 3, then subcell also n equals to 3. Subcell is also 3. And number of orbitals is n square. This will be 9. And number of electron will be 2 times multiplied by 9, that is 18 electron, because 1 electron can have maximum, an orbital can accommodate maximum 2 electron with opposite spin. Which species is hydrogen like? Hydrogen like means hydrogen has 1 electron only. This consider 2 electron. This is also considered 2 electron. This is 1 electron and this is 2 electron. You know Z of all these elements. Helium has Z2. Electron will also 2. Lithium has Z3. Lithium plus has 2 electron. Helium has Z2 plus 1. 1 means 1 electron is lesser. And beryllium has Z4. 2 electron is lesser than 2 electron. If photon wavelength decreases, photon increase. Photon energy. Photon wavelength, we know E barabar hc by lambda. If we decrease wavelength, then energy is increases. So your correct answer is this. Number of orbitals in d subcell. So you have to decide what is the number of orbitals in d subcell. So this is d subcell and orbital number is 5. So these are the simple questions related to this. Now next these are the questions which we have solved. So next, what we have discussed in entire chapter, Rutherford model, radiation, and de Broglie concept, Heisenberg's uncertainty principle, Bohr theories, quantum model, and electronic configuration related 3 rules. Now there is some simple problems related to atomic structures we have to solve. So first is what is the all 4 quantum number? Question is what? What is all 4 quantum numbers of last electron of sodium? Question is what? All 4 quantum number. All 4 quantum number for last electron of sodium. So what we have to do? You have to do first write electronic configuration of sodium. So you have to write 1s2, 2s2, 2p6 and 3s1. So last electron is this. Principal quantum number equals to 3. Azimuthal quantum number equals to 0. Magnetic quantum number is 0. Spin quantum number is plus half and minus half. So this is some simple basic question. Next question is what? Question is what is the n plus L value if I take n plus L value equals to 0, then tell how many electrons are present in magnesium for satisfying this equation. Magnesium may how many electrons are present which satisfy this equation. So for that also you have to write 1s2 electronic configuration 2s2 2p6 3s2. This is magnesium configuration. Now check n plus L0. Sir, n1 L0. Sir, n2 L0. Sir, n2 L0. Sir, n L0. So there is no single electron which have n plus L equals to 0. It means these are 0 electron. Okay. Next question is you have to find n plus L equals to 0. Now, next question is what? In selenium Z34, you have to find L plus M equals to 0. इस इक्वेशन को सेटिस्फाई करने वाले नंबर ऑफ मिनिमम एंड मैक्सिमम इलेक्ट्रॉन. मिनिमम एंड मैक्सिमम इलेक्ट्रॉन which have L plus M equals to 0. Or I can make this question as easy if you have only this M equals to 0. So first we try for M equals to 0, then we will see another question with L plus M equals to 0 likewise. So what is selenium configuration? 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. What is Z? This is 30. I think this is 30 and 4p4. I think this is 30 electrons are filled till this, and next remaining are this 4p4. So M will be 0. So this 2 electron L 0, then M also 0. Here also M 0 2 electron, M 0 2 electron, having M 0 2 electron, having M 0 2 electron, having M 0 2 electron. Because in D there are 5 orbitals which have M equals to -2, +2, +1, -1, 0. And in this 4p, if we want to this, then this, so you can say M this also 0 or this also. If you consider that this is M equals to 0, then you have to count 2 electron, and if this is this M equals to 0, then you have to count 1. So this is your maximum answer 16. I think 2, 4, 6, 8, 10, 10, 12. I think you understood. This is minimum 15. Next question is, you have to find out principal quantum number for 21st electron of chromium. So first of all, we have to write electronic configuration of chromium. You know, chromium is at 24 and configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 4s1 and 3d5. I think this is configuration. Now 21st electron is till this 18 electron are filled up, this is 19, this is 20 and 21st electron is here. So principal quantum number is 3, L is 2, M is D के लिए L2 होता है, M is -2, -1, 0, 1, 2 and S is +½ and -½ So total number of possible sets of quantum number for 21st electron can be made. So you can say 1 set. Now for 5 set is for this and multiply by 2 because we have S +½ and -½. So total possible set is 10 set for quantum number. Okay. Next question is that you have to find which quantum number is set is incorrect. So there are N, L, M and S principal quantum number, azimuthal quantum number, magnetic quantum number and spin quantum number. Here is some 3, 2, 1, -½ You have to decide that this quantum number is correct or not. So you have to say that N is greater than L, M is -L to L and S is -½ then this is correct. Okay. Now, principal quantum number is this, azimuthal quantum number is this is this, and this is plus half. So this quantum number will be, this set of quantum number is incorrect. Why? Because n never becomes, n always greater than L, n and L never become equal. So this quantum number set is incorrect. Now, quantum number is, principal is 5, 4, then minus 5 and plus half. This quantum number set is also incorrect. Why? N greater than L, no issue, but M always minus L to plus L. Minus L to plus L. So minus L to plus L, M is not matching, then this quantum number is also incorrect. N is 5, L is 3, this is minus 4, and this is plus half. N greater than L, there is no issue, but M is minus L to plus L. So this number not lie in this, it means M is wrong. This quantum number is also incorrect. Next question, if I change that L is 0 to n plus 1 and nothing is changed, only this change is made. We have to assume L 0 to n plus 1. So if n is 1, then L will be 0, 1, 2. Now n equals to 2, then L will be 0, 1, 2, 3. N equals to 3, 0, 1, 2, 3, 4. Likewise, now I have to write electronic configuration for selenium. Now also you can write 0, 1, 2, 3, 4, 5. So for n equals to 1, there will be 1s, 1p and 1d. 1s, 1p and 1d. For n equals to 2 is 2s, 2p, 2d, 2f. N equals to 3, 3s, 3p, 3d, 3f, 3g. And 4s, 4p, 4d, 4f, 4g and 4h. Now energy order will be decided by this path. So we can write energy order also, then that is 1s, 1p, 1d, because L was 0 to n plus 1. So if we write n equals to 1, then this will be this. Then for 2s, 2p, 2d and 2f. 3s, 3p, 3d, 3f and 3g. Next, if you want to write 4s, 4p, 4d, 4f, 4g and 4h. So energy order will be decided by this. 1s, 1p, 2s, 1d, 2p, 3s, 2d, 3p, 4s, etc. I think you can understand the energy order will be this. Now we have to write electronic configuration of 34 selenium. This will be 1s2, 2p6, this. What is the number of electron till now? 2, 6, 8, 10, I think 10, 20, 6, 26, and this is 36, but you have to write only 34, so you have to write 8 here only. So your configuration will be 1s2, 1p6, 2s2, 1d10, 2p6, 3d8. If this was for selenium, so this will be very helpful for your score examination. What is score examination? India's largest talent search exam, by which you can get case reward, scholarship, educational trips, etc. So this slide itself tells about what is the features, what is the main things in a score examination, that is case rewards, scholarships, educational trips, and many more rewards you can achieve. And for this, there are 4 steps. First of all, we have to registration process, then verify by filling details and select your exam center, timing also you can select, and third step is some small amount charges for this examination, and finally you can attempt your test. Next, for our side, exam date, there are 2 facility for exam date that you can select. If one student are not able to give examination on this date, 4th October, and then you have another option, 1st November 2026 also. So by these 2 options you can select your convenient option for examination. And if students which so these are exam dates for scholarship for school and college student for Sri Chaitanya, and these are the exam date for Sri Chaitanya Coaching and Academy, and that is 11th October 2026. And this is our website, www.srichaitanyascore.com. You can Google this website, go and see all features related to score examination. And you can like, subscribe, share these our social media platform, by which you can get further updates regarding score examination and other events which are scheduled for upcoming session at Sri Chaitanya. So for now, all the best beta for your score examination.